Morning, everyone. Welcome to Hereticals. It's debate day. Today's actually not a debate. Today's an actual discussion. We have round two with almost a Dr. Matt and Otangelo. How does science work and why doesn't it come to the conclusion of God? This isn't going to be a debate format. This is going to be a discussion format. So basically, I'm going to be sitting back and just listening like the rest of you. I will only come in if I don't feel that the conversation is progressing, or if one's over talking the other one too much. These two usually have a pretty decent conversation, so I don't think I'm going to be in here much. So I'm going to bring the guests in and let them start everything and good to go here. So, Matt, did you guys and Tangelo, did you guys figure out who's going first? I didn't get that one.
I'm happy either way. Otangelo, do you want to go first? I'm happy to offer that to you.
Whatever is okay for you. For me, it's fine. I can start. I can make the first comments, and we start from there.
All right. Well, with that, we'll let Matt start. And like I said, I'll pretty much just be sitting here watching like everybody else.
All right. So what I'm thinking then is I'll just start with the general comments about my current beliefs on this topic, and maybe we can go from there. You can add yours, and then we can get into the discussion. I know this is meant to be fairly laid back. So, Otangelo, if you want me to clarify anything, just let me know. Just speak up. It's not a formal debate, so I'm not going to get fussed about that. So, yes, obviously, because I'm on this channel, and well, maybe not so obviously, but yes, I don't believe in a God. I don't think that there is one, but that's not to say that I believe there isn't one. So my thoughts is that there are still ways you could potentially prove a God, but I doubt it would ever be anything close to the Christian God. I think in terms of what we know about science, it's definitely not a young earth God, or at least a young earth belief. We know the earth's not young, or at least as close to absolute certainty as we can get on anything. I think the earth is not young in that sense. But the reason, even though there are many scientists out there who are still religious, generally speaking in science, there's very few who are young earth, or there's quite a few old earth creationists that come to mind, but a lot of them still separate their religion from their science. And you actually have a lot of cases where they'll say that in the lab they're an atheist or they're a non-believer, but outside of it they're as spiritual as anything. And I think that's kind of where it falls, that it's not that you can't be religious and a scientist. You can be both of them. But when you're doing science, as of yet, there isn't anything in there that proves religion or that comes close to the way that religion works. So therefore, at best, you don't really have anything to kind of like, you don't really have a basis for like a God belief or anything there. Or at least so far, the ones that have been testable, and I know I'm bouncing around a bit, but I swear I'll get to my point. But in terms of actually, and that distracted me. I shouldn't have done that. But in terms of like coming to the conclusion, if there has been testable things about religion, say the efficacy of prayer or how old the earth is, all of those have come back not in favor of the religious position. Now, that's not to say that 100% proves not. And as I said, I'm still open that there is some possible supernatural element out there that is yet to be proven, but that's the key part. So far, nothing in science that I'm aware of has come close to that, and that's mainly because of that testable part. There is not a falsifiable kind of test for God that you can do, and so as a result of that, until you have a test that you can run, science can't come to the conclusion whether a God exists or isn't. However, the fact that there is no evidence means that, as of yet, the conclusion is, well, there's no evidence, so we're going to go with it's not likely, particularly if you would expect there to be evidence. So I know that was a tiny bit rambly, but hopefully that starts us off. Otangelo, what do you think?
Yes, I think there cannot be any test whatsoever to prove God's existence, because we are talking here about something which lies beyond the physical and our universe. So all we can do is using abductive reasoning to the best explanation, or eliminative inductions, in the sense that if the no God hypothesis fails, then the alternative, it is the only one, which is God, which I think is actually the only alternative, becomes the better alternative, the better hypothesis, even if we don't know actually how God operates, how he can create and instantiate the physical universe. Yeah, I know that the preponderance is that the young Earth interpretation in Genesis isn't scientific, that the major part of scientific evidence points to an old Earth. And I agree actually on this one, even myself being a believer in a young Earth, mainly because I think that Genesis is best interpreted as such. I agree that there are difficulties like the starlight problem. I've investigated the answers given by some who propose that it can be solved, and I have actually not seen any compelling explanation in regards of this. But on the other hand, the Big Bang model has also its problems, like the flatness problem, and things that are proposed like inflation, which I think also there are severe problems with this. So I would say that both models, they have problems, and in the end, it is just about what someone has a preference for. But I mean, there are many older creationists which go with the majority of scientists, but that doesn't say that therefore they don't believe in God anymore. They try to unite both proposals, and to have come to a convergent point in regards of that. So I don't think that the fact that the majority of scientists think that the evidence points to an old Earth, that or an old universe, that means that God isn't plausible anymore. Yes, there are scientists that are religious, but I don't like actually the distinction science versus religion, like as if it would be two competing hypotheses. I don't think they are. I think the quest is about good science versus bad science. The quest is, here is the scientific evidence, where does it lead to? What are the best explanations? And the two competing hypotheses are a God against no God. Either there is a God which instantiated it all or not. Now, in the end, this is not a scientific but a philosophical issue. So we have the scientific evidence, and the big question is, where does it lead to? Does it lead to God or to the no God proposition? What else you said? There is no basis for a belief in God. Well, I think the fact that we cannot test God in a laboratory, in a test tube, that isn't a good reason to say there is no basis for belief in God. I think when it comes to this big question, which is basically what forms our worldview, then we have several reasons and lines of evidence that we need to put on the table and weigh against each other, and then eventually come to a conclusion. And I think that, of course, God, we cannot expect in the laboratory to see God fiddling there somehow and then doing a miracle and something happens. That obviously will not going to work. I think that in operational science, it is right that, I mean, even if a scientist is a religious believer in God, in the laboratory he will always expect that something natural happens. If he has a protein which he doesn't know or understand its function, then he will try to understand the natural proceeding of or function of that protein. This is obvious. I mean, miracles, they are always something which should not be expected to occur in a regular basis. But when it comes to historical sciences, there, in my understanding, is the problem why the current scientific philosophical framework is flawed. Because in operational science, okay, we should just use methodological naturalism, but in regards of origins questions, we should put all the possible and competing hypotheses on the table and then evaluate one against the other. And when it comes to things that happened in the past, then all possible explanations should be permitted to be considered. And when eventually things that we observe in the past point to intelligence that would have had to be involved, then it should be permitted to say, okay, I see abiogenesis. It seems that there are features there that best are explained by an intelligent designer. I think the problem in modern science is that it doesn't permit a priori that explanation, and that's where I have a problem with.
Okay, no, I think that's fairly useful too. So this is going to surprise, well, this surprises me, but probably might surprise a lot of people in the chat. I agree with a fair bit of that. Now, the ending, obviously not, because otherwise we wouldn't be sitting here on kind of opposite sides, at least metaphorical sides. But I would at least agree with the basis that it is about good science versus bad science. Where I think we might start to differ is on how you could test for a god. I would agree that as of yet, yes, you're right. There probably isn't a way to test for it in a lab. But to me, that's enough to say, well, then I can't find a basis to believe it. If you cannot show me, and I don't mean this in the traditional, show it to my eyes. I'm a spectroscopist and a physicist. I work on the basis that I'll use tools to find it, or we can work off other methods and kind of inferences, I guess, to figure out what's going on. But when it comes to like the reason why science can't is that science is by definition limited to methodological naturalism. Sorry, I can't even speak at the moment. But that's doesn't mean that you get to put all of the options on the table, because yes, while at first you could put them all on the table, they're not all equal. This idea that God versus no God is equal, I don't think is the case. I don't think you can say that they're the same. And there are scientists out there who would be religious who'd probably fall more on what I believe closer than to what you believe, although that's probably not saying much, as you've already yourself pointed out. I guess to also tackle the comment that's been brought up there by High Inquisitor, for science to be able to test something and come to a conclusion, you need it to be falsifiable, and you need some method to determine it. You can't make a priori assumptions like that. It just doesn't work that way. And I would say, even from a philosophical point of view, you can't really just assume something's the case, like, oh, the supernatural exists and let's go from there. Even with the basic laws of logic that I know some people say we can't prove them. Yes, I would agree with that, but you can show that they work. So, for example, like the laws of non-contradiction, or the law of non-contradiction, etc. I'm not a philosopher, so I'm not going to get too much into it. You can take those laws, you can develop the philosophy of science with them, and from there, you can go and do all these other tests. You can show science works. The fact that we're talking to each other from opposite ends of the world through technology that 50 years ago would have been only in the imaginations of some of the most creative people, I think shows why these assumptions or a priori sets work. But if you're then going to add a God in there, you should be able to do the same thing. Even if you don't understand, as you pointed out, exactly how it works, exactly how God works, the supernatural works, you should still be able to test or show that as a tool it tests and it works. You should be able to show its usefulness into coming up with new ideas. And I would say that it kind of fails in that regard. But there's a couple of other points I did want to talk about too. But if in terms of if you want to get into the exact methods of how science works on some of the young Earth stuff. We can maybe leave that for a bit later, but I think that could be interesting as well. But I've been talking for a bit, so do you have anything to respond there before I go on?
Yeah, I will respond. I wrote down a few points which you mentioned. Okay, so in regards of testing God, I think that scientism or verificationism is not a sound epistemological framework to investigate.
So can you just when you say scientism, what do you mean by that? Just so we're on the same page.
Yeah, the philosophical epistemological approach that only what can be tested is a valid proposition in regards of investigating origins. I think that this framework has been left behind in philosophical circles about 60 years ago, and philosophy and theology have become also a valid tool to investigate origins. So I don't think that only saying that what can be tested and shown to be true is valid to be believed and to acknowledged. And of course, I cannot demonstrate God's existence. He doesn't show up, and we can investigate him or even.
Okay, so sorry, I just want to, if I may, I don't mean to be rude interrupting. I just want to clarify something because I want to see where this goes. So when you're talking about kind of scientism and the problems with origins, and how you're talking about how now theology as well as some aspects of philosophy can get you to answers for origins. When you say, can you give us can you give me specifics on where this has actually worked to discover something new outside of, say, the origins of the universe, when this methodology has been shown also to work elsewhere and has come up with like predictive power?
Yeah, what we are trying to elucidate is the history of ourselves, of the universe. So we are not trying to understand how something works in nature. So these are very distinct and different questions. As soon as you try to understand what the function is of a protein or an organelle or something like that, then of course God shouldn't be invoked, because we are trying to understand how things operate regularly in the natural world. But when it comes to explain what happened in the past, as I said previously, the quest of origins, of why there is something rather than nothing, this is basically a philosophical and maybe as well a theological question. And I don't think that it should be excluded. And we shouldn't expect to find absolute proofs in regards either of the God hypothesis or the no God hypothesis. I use two methods, which is abductive reasoning to the best explanation and eliminative inductions, which means if we test something in the lab and it doesn't work naturally, like abiogenesis, it has been tried out in over 60 years and it hasn't provided good reasons to conclude that just natural things can instantiate the complexity that we see in life, but rather it has unraveled more and more complexity, which drives us further away from a naturalistic explanation. Then if natural explanations are eliminated, then whatever is left is the better explanation. And then I think we can rationally conclude that intelligence has to be involved somehow to instantiate the complexity that we see in the natural world.
All right, Otangelo, he wants to come in to respond to something real quick. So
yes, so when you, in particular with the abiogenesis, but I'll get to the specifics, when you more generally said once you've eliminated all the other options, then you must be left with the supernatural, or at least when you've eliminated the natural options, you must be left with the supernatural. Is that what you're saying?
Yes, this is one part of the framework, and the other is positive evidence. If we see traces of intelligence, which was required to instantiate certain feature which we observe in the natural world, then this adds up to the bankruptcy of natural explanation.
Okay, so We can come back to the intelligence bit, but I want to address that first bit, because how do you know you've eliminated all natural options?
Well, we have basically, once you remove intelligence from the picture as a causal agent, then you have, what do you have left if the universe was not instantiated yet? So let's suppose the scenario where there is no universe.
I'm sorry, I was specifically referring to the abiogenesis example, if you want, for that. I'm happy to move in that, but say when you were talking about abiogenesis, how do you know you've eliminated all the natural possibilities?
Okay, there are basically two options here. One is physical necessity, and the second is unguided random events. I don't see any other further option. If you know one, please mention it, and I am more than happy to acknowledge it. In my, let's say, in my investigations, I've not seen any other possible alternative mechanism or explanation.
I don't think once you have established the basic, kind of rules of physics, I don't say that the chemistry that follows from that is random. And I don't like anything to do with evolution or abiogenesis. And I will obviously make the distinction that they're separate. I don't consider them the same thing, although one kind of then led to the other one. I don't consider it to be completely random processes. There are selection pressures that are given by, well, specifically with abiogenesis, by the chemical environment at the time. And this idea that we've haven't gotten anywhere in the last 60 years with it is nonsense. You might be thinking from the Miller-Urey experiment to now, yes, we haven't been able to create life or prove exactly how it started, but our understanding of the chemical building blocks, the chemistry of what would have gone on, potentially building cells, making artificial cells ourselves, all of that, we've got a long way. Like, yes, I have a mainly physics background, but I also have a major in chemistry as well. I did study a fair bit of organic chemistry, so I'm happy to talk on some specifics if you want to bring them up, though it's not something I spend a lot of time studying. But in terms of our understanding of chemistry and how it works, yeah, I'm not surprised we haven't got an answer yet. We've had 60 years. Nature had probably millions of years. And we're talking about an event that was, about somewhere between 3.5 and 3.8 billion years ago, because unfortunately the geology is not, it doesn't last long enough for us to be able to show exactly when it started. And so it gets more difficult after 3.5 billion years. But we can leave that for another point. The problem I have here is that you're saying that somehow we've shown that there isn't a natural way, whether that's, from random processes or from, physical necessity, or I'd say it's more like a spectrum. You can be in between. Like, it's not necessary that, humans evolved or humans and our ancestors, specifically our ancestors, evolved eyes, but it's definitely a lot of evolutionary pressure for us to evolve them, or at least some light sensing organs. So in that case, it's not just random. The mutations themselves, the chemicals, the exact positions of them might be random beyond, the quantum mechanical nature of the interactions with the bonds. But that still doesn't mean that we have the ability to show that all natural options have been left off the table, because you seem to have narrowed it down to two. But within those two, that's what I'm saying, it's more like a spectrum. There are still billions of combinations of chemicals that could potentially start life. And even if and it's one of those things where I don't think we'll ever have the exact answer. It's just not possible to know how it started. But that doesn't mean that we get to rule out natural explanations.
Okay, first of all, I disagree in regards that we can bring also natural selection into the picture when it comes to the origin of life. And I'll quote here from a paper from Mario Vaneketten's The Scientific Origin of Life from the year 2000.
Okay. Can you just put the DOI or the link in the chat here just so I can read along?
Yes, just a moment.
Yep. Sorry, I just want to make sure I've got it. So I am not just trying to remember everything you said, and hopefully we don't talk past each other. Thank you. Sure.
I will give you also the link to the entire, from my library. There are many other sources, and eventually you guys can put it in the side chat so anyone can can follow what I am saying here. So I'm quoting here from that science paper, and he says, we hypothesize that the origin of life, that is the origin of the first cell, cannot be explained by natural selection among self-replicating molecules, as is done by the RNA world hypothesis. So I have many other sources, and you guys can look it up. But the fact is that molecules, they have no urge to a specific outcome to survive, because there was no life. And in order for natural selection to be operating, there are many things that need to be in operation. So if you have things that are reproducing their kind, and if there are sometimes random variations nevertheless in the offspring, if such variations can be inherited, if some such variations can sometimes confer an advantage on their owners, if there is competition between the reproducing entities, and if there is an overproduction so that not all will be able to survive to produce offspring themselves, then these entities will get better and reproducing their kind. What is needed for natural selection are things that conform to those ifs. Self-replicating cells are prerequisites for evolution. None of this was available prebiotically to explain the origin of the first life form. So I disagree with you that natural selection is a viable explanation. And the classic, which I always bring up, and I think I did it in our last conversation, was in regards of the amino acids. You mentioned the Miller-Urey experiment in regards of how those emerged, and supposedly there were over 500 different amino acids around prebiotically, but life owes only 20 amino acids. So they would have had to be selected amongst these 500. And this is a very deep and big abiogenesis problem, which I think only this evidence demonstrates that abiogenesis is not possible, because molecules, they don't have the urge to select themselves to then become functional proteins over time. So if you think carefully about only this problem alone, then I think it is powerful evidence which demonstrates and evidences why unguided random events cannot produce life, because the set of 4 basic building blocks have to be selected, have to be made. These are complex molecules. RNA, DNA is very complex. It is very complex to synthesize them in the cell, and so the others as well. And
Otangelo, hang on. Otangelo, hang on. You've rattled off a lot of stuff right there. Let's give Matt time to respond to some of it, because we don't want you monologuing. We want a discussion here.
Yeah, sure. Go ahead.
Yeah, okay. So there's a couple of things. So 2 main things I want to address and try and make it a back and forward. So with that paper, when you read that quote out, I think I found the spot, and then also looking at the beginning bit, they cannot be explained by natural selection among self-replicating molecules, as is done by the RNA world hypothesis. This paper is only referring to problems with the RNA world hypothesis. However, this was also published in 2000. In the last 2 decades, our understanding of chemistry has come a long way. What you're saying is that there is no drive for molecules to become self-functioning, I also think is just incorrect. Yes, it's not natural selection in the terms of evolution, but that's why I said that these are not the same thing. Once you have the cell and it's capable of reproducing with error, or at least with the chance for error, then you can get evolution. But before then, you're saying that it's not possible, whereas mathematically, just from a thermodynamics point of view, mathematically, life speeds up the increase in entropy, or it flattens out the energy to make, so if you're looking at entropy gradients, life speeds up the increase in entropy faster than not life. So mathematically, there is actually a drive to create it, just from that point of view. So I would disagree with that bit as well. So to address those two. So this paper wasn't referring to the fact that there is no natural possibility. They're saying as of yet, we don't have a natural selection on its own won't explain the RNA world hypothesis from what I can see of the paper. But as I said, it's also 2000. I'd be a bit more curious for later ones. Sorry.
I just want to ask a question here. Otangelo, do you know when this article was written? Because the references in this article, the latest one I seen was 1998. So the information here is a little outdated. Can you
Okay.
do you know when this paper was written?
Yeah, in 2000. That's what
Okay.
I have.
Okay.
That's what Google
here.
Scholar's telling me, because I've got access to my to the database from
Okay, yeah. So,
the library
Matt
database
said,
through the uni.
it's in terms of science, it is a little outdated. But I'll let you guys go.
Yeah.
Go ahead.
Sorry, I was talking for a bit. Otangelo, what if?
Yeah. So I think that molecules left by their own, they will not complexify. And I can quote here from another paper, Paradoxes in the Origin of Life, from Stephen Benner. I will put the
What year was this one?
Chat. It is from 2012. Okay, here's the link.
A little newer.
Yeah, and it says, the asphalt paradox, the systems given energy and left to themselves devolve to give useless complex mixtures asphalts. The literature reports to our knowledge exactly 0 confirmed observations where replication involving replicable imperfections emerged spontaneously from a devolving chemical system. It is impossible for any non-living chemical system to escape devolution to enter into the Darwinian world of the living. Such statements of impossibility apply even to macromolecules not assumed to be necessary for evolution. So rather than molecules left on their own prebiotically to become RNA and DNA and carbohydrates and phospholipids and amino acids, they would just disintegrate and not start to self-replicate and then become more and more complex in the end to have a first replicating cell.
I'm not sure where this paper's getting that from, because we've already shown in the lab that's incorrect. We've already been able to make basic cells that on their own will grow and will feed and are fairly self-sustaining. We've made, not quite built like anything like life like it is, but we've come very close. And that's why in science, you generally don't reference anything from more than about 5 to 6 years ago for the basis of your work, unless you're referring to like the start of an area. If you're talking about something like this, which is a field that tends to adapt very quickly. And
yeah, you know what you are
look, I don't quite follow all the words there, because it's not something I've heard. Like, I haven't heard this before. So do you understand what they're talking about when they mean complex mixtures such as asphalt?
Yeah, asphalt, that is like tar. It is full of impurities, and it is not something that would become closer to a building block of life, like DNA, RNA, phospholipids, amino acids, or carbohydrates. So let me reference what you said, that we came closer. And I think that you are referencing to Craig Venter's experiment in 2009.
I'm referring to multiple.
Yes, but this is the most prominent one. There was an article in Science, Creation of a Bacterial Cell Controlled by a Chemically Synthesized Genome, that was published in 2010. Now, the only thing that Craig Venter's team was, they transplanted a genome from a bacteria, from a recipient cell, to create a new mycoid cell. So there was just a transplantation of that genome. That comes not even close to explain the origin.
That's
of life
not the experiment I was referring to.
Well, here, okay.
I mean, you could add that into the list, but I'm referring to more simple chemical experiments where you make basic cells that not necessarily kind of replicate in the sense that we understand them or have DNA or anything like that. But as I said, this is not specifically my area. So,
Matt, do you have an article we can take a look at to go along with that? Do you have?
I will try and find them, but I don't have any off the top of my head. So that's why I was hoping, like, I can cover only the generals with this. This is not an area I've spent too much time. I'm more into physics. So I can talk about specifics once I have an idea, but general quotes like this, because the link I got is only to your blog, Otangelo. I can't see the paper, so I can't go in and have a look at that. So for this one, yeah, I haven't seen that before, but if their conclusion is that it's impossible for any non-living system to become living, I disagree with that.
Yeah, I mean, that is just one reference which I gave you. I have many other ones which substantiate what I just said, and I can give you newer ones like, for example, open questions in origin of life experimental studies on the origin of nucleic acids and proteins with specific and functional sequences by a chemical synthetic biology approach, February 2014. And I'll give you the link afterwards, but quoting here, attempts to obtain copolymers, for instance, by a random polymerization of monomer mixtures, yield a difficult to characterize mixture of all different products. To the best of our knowledge, there is no clear approach to the question of the prebiotic synthesis of macromolecules with an ordered sequence of residues.
And that's a lot of words, but it's still, we don't get past the problem that even if we rule out these specific ones, that doesn't rule that doesn't rule natural processes out completely. It doesn't come close to it because there is no way we can tell we've eliminated all the natural options.
Well, again, I think the key problem here is that you have actually no natural selection. And in order to start even the complexification, you need a set of very complex and specific basic building blocks, which I mentioned already. And these are also complex. And for example, one of the very basic and necessary elements and atoms is carbon and nitrogen. Now, the problem here, Matt, is that, for example, nitrogen has to be in the form of ammonia. And it doesn't simply exist naturally. Usually nitrogen is in gas form in the atmosphere, and it has to be fixed. And today, there are very complex microorganisms like cyanobacteria, which use nitrogenase, which is a protein which actually fixes nitrogen from the atmosphere and then produces ammonia. And then from there, it enters the food chain, and it can be used to make DNA and amino acids and the basic building blocks. But the problem is that prebiotically, this very complex enzymatic and energy costly process of nitrogenase enzymes wasn't there. These proteins or enzymes weren't there prebiotically. So you have already the problem even of the availability of nitrogen. And carbon is the same problem. You need to fix carbon from carbon dioxide in the atmosphere. And that there are 4 different cycles, metabolic cycles, which do that process, which also wasn't available prebiotically. And that is the metabolism first approach. And Shapiro has said it very clearly in the end, in 2008, as far as I guess, that all these proposals, they are a failure because life uses at least 9 or 10 enzymes for that process, like the Wood-Ljungdahl cycle, and that cycle wasn't there. So they think that they can use some kind of clay or metals that would have done that process prebiotically. But how would you go from that process then to the enzymatic process, which is a huge step? It is like
it's a huge step that had hundreds of millions of years. And as I said, this is not my area. I'm not pretending to know the specifics. And I'm also not sitting here saying that we figured it all out. What I'm saying is that there is no way to prove we've eliminated all natural options. Even if what you're saying with these papers, all of that, at the end of the day, even if it's true, all it does is show that that's not how it occurred. Something else may have happened. I don't think that it is possible to prove that it couldn't be natural, because chemistry is complicated. It is very difficult. These days, if you have a molecule, like a chemical structure that you want to make, good chances are you can make it now. We have the methods to do so. But it is hard to do. Like there's so many steps and ways of doing it. Now, we're also then, if you want to take this back, we're trying to guess is the wrong word, but we're trying to figure out what is likely steps of how we get to the life that we have now. But chemistry is not simple. Chemistry is complicated. There are so many possibilities that even if we eliminate all the ones that we think are intuitive, there might be something we've missed. And to go from, well, this doesn't work for the origin of life, or that doesn't work for abiogenesis, to therefore it must be supernatural, is too much of a leap. And that's why science can't get there, is because even if you eliminate all of these, you still need some falsifiable test to show that it was supernatural. You can't just assume you've ruled out all the natural options, because there's no way to get there.
Yeah, I mean, I start from that premise, Matt, that we only know that life can come from life. And we have absolutely no evidence that life cannot, that life can come. We have no evidence that life can come from unguided random events. And so far, science
this is what I said. It's not random. It's not, when we talk about these processes, it's not random. There are governing like physical and chemical laws and processes that mean that it's not just like a roll of 1,000 cosmic dice. That's not how it's working. And it's also why we're trying to look for life on other planets, because that will give us, if we ever find it or we don't find it, will give us a better understanding of how it goes here. And I'm more suited to be able to talk on those because I've actually spent more time looking into them. But what we get to is that it's not random, but it's still difficult to figure out the exact specifics. But it doesn't matter how much of these individual specifics that we rule out. You still need a test. And this goes back to how science works. You need to come up with a test that shows, or at least enables us to prove that it was supernatural. You don't need to understand how. That can come later if it comes at all. But you still need a test to show that it was supernatural. Because I could sit here and let's say I've got my bottle here of nice Islay whiskey. I have a couple of these bottles anyway, although this one's getting old now. I could say in here, well, what are the chemicals? And let's say I'm not allowed to go to any of my labs and run spectroscopy experiments. I could sit here and I could prove that it's not got arsenic in it because I haven't died. That doesn't prove what's in it. And this is what I'm saying. I could go through so many chemicals and show that they're not in here, but that still doesn't demonstrate what is in there. And that's what I'm saying, similar to this one. If you're going to say that, the origins of life can't come naturally, you need to show how they came. Otherwise, all that we can do, and this is my position, is, well, it's most likely to be natural because so far no one has demonstrated the supernatural, and most of the tests that have been developed for it have in one way or another failed, although I'm using that word fairly loosely. So you still need to demonstrate that supernatural element to it. And I'm not sitting here saying this is how life started. Maybe there was some freak event where it was not normal, what we would consider normal chemistry, because it's quite possible that life started a lot earlier than originally was thought. So that would mean that the conditions on Earth were different. So it's not also then going to some of your early points, the same to say that, these nitrogen fixing processes needed to be in place, because we don't even know that the early life needed those. There's evidence to suggest, or there was, particularly from synchrotron studies down on rocks from WA here, that showed that it's possible that early life, even some of it, used an arsenic cycle for energy, which is chemically very different. And so, but that's a bit of a tangent, but what I'm trying to show with it is that it's not that simple that you can just sit there and rule out everything else.
Okay, you said that supernatural has never been demonstrated. As I said previously, Matt, events that have occurred in the past, of course, they cannot be shown because we have no time machine to go back and to actually observe what happened back then. So I think it's not about showing the supernatural. It is about looking into the evidence that we have today into the natural world, and then try to see if there are actually signs that intelligence was necessary to instantiate the complexity that we see in the natural world. Now, you said that chance wasn't the only option, but there was also eventually physical necessity or physical processes which
you brought that up. Sorry,
yeah,
I was just saying that it's not
but,
necessarily one or the other. That's all I was pointing out.
Okay, so I will address that. Well, what we know is that all life forms, they have a genome, they have DNA, and they need information which is stored in the DNA. And that sequence of nucleotides which conveys the information, how to make the building blocks of life, how to make proteins, and how to make the microRNAs which have regulatory functions. So there is a specified complex sequence there that has to be just right. And you cannot invoke physical necessity in order to explain the origin of that information. Okay. Now, in regards to what you said, that eventually first there was an arsenic cycle, and then the question, of course, would be, well, if that is the case, why do we not see any life forms which still use these kind of materials and cycles, and rather arsenic rather than nitrogen? And secondly, even if that were the case, to go from an arsenic-based life form to a nitrogen-based life form, that would require an entire different setup and a transition. That would be the same to say, well, there is a bicycle and then you have a motorcycle. How did that transition occur? If
no. Bicycles and motorbikes don't reproduce. It's not the same.
Well, can I finish, please?
Well, you actually asked him a couple questions there. Give him a chance to answer the questions before you keep.
So going. I'm actually having trouble remembering them. So I'm happy for Otangelo to quickly finish and then ask me what his questions were. But I will push back on that one thing about the bikes and the motorcycles, because they don't reproduce. Life reproduces with error. So if you can show me machines that do that, then it becomes analogous. Sorry, it's a common mistake I've seen. I don't mean to get too worked up, but it's hard because that's one of the problems in science communication is the use of metaphors. And it's a balance between using them to make it easier for people, but at the same time, the more you use them or the easier you make it, the bigger the chance you are for misunderstandings. So, and I'm pretty sure I'll be bringing that up again later if this goes where I think it might be, but I will leave that till it does. I'm not trying to predict anything. Sorry, those aren't the same things. But what were your questions again?
Well, I mean, I like metaphors because it makes it illustrative and exemplifies what we are talking about.
They're good. You just have to be very careful with them.
Understand better what we are talking about. But I would like to come back to the metabolic cycles, which are necessary, for example, to fix carbon dioxide to make carbon, which is all the basis of all life that we know here on Earth. And I would like here to quote from Leslie Orgel. I can give you afterwards the link. It is the implausibility of metabolic cycles on the prebiotic Earth. He says,
I don't think we'll need the link because, as I said, it's not my area. There's probably not a lot I can say on that. If you want to get more to some of the physics ones, I can probably have a better say. But unless I go away and look at them, it's not going to help too much. But I would just go back to my earlier point. So I don't mean to be dismissive. I just think that in terms of practicality, it'll save a bit of time. Because, I could say you can prove all these methods are wrong, but you still need to show that it was supernatural. And if you're correct and there is no way of showing it, then the best we can do is say, well, we don't know.
Okay. I want to make that illustration. If you see a factory, and inside of the factory, you see a production line of several robots lined up in a functional way, where you start with the raw product and then it goes to the first robot, and that first robot makes the first manufacturing step and there comes an intermediate product, and that intermediate product is handed over to the second robot, same process, and you have 17 robots lined up in a functional way, and in the end you have an end product which then is still used in a higher end or more complex system. And then I ask you, Do you think that the make-off, that production line, is better explained by the injection of intelligence, of an intelligent being which instantiate that production line with a specific purpose to make that product in the end? Or do you think that it is rather or better explained by a random unguided process that over millions of years came up with that production line?
Now, if you're so, this is why you got to be careful with your metaphors, because if I came across a factory and saw robots in it, we know factories don't occur naturally. We know that you need an intelligent agent to build a robot. So by that, yes, I could say in that case, that specific case, that it was more likely that it was built by some intelligent life, whether that was humans or something on another planet, because there's no other life on this planet that can build like that. And, well, although we haven't found aliens yet that can do that, but that doesn't mean they don't exist. The universe is very big. However, can you show me an example of robots like that in nature? Because every example I've seen has flaws with it. They are not analogous. The idea that DNA is a code or has information, or that these processes are perfect, is just nonsense. That is one thing that comes up very quickly in science when you're studying chemistry and biology, microbiology, is that these processes, whilst they are complex, they are not only needlessly complex, we've also found better ways of doing them. There's a certain reaction, I think it was a Grignard reaction, or I think it was that one. There's a particular catalytic process that was just never seen in nature, and it turns out that if you actually come up with certain enzymes that humans design, you can actually make it work in nature. So it's just a weird thing that's been skipped, even though it was a more efficient way of doing it. And if you want to bring up all of these, these robots in nature, we don't see that. These chemical processes, yes, might be analogous to being a robot, but they are terribly inefficient on the most part. And where they're efficient, it's only because, the pressure of billions of years seems to have made it efficient. So okay, I guess then my question is, can you show me one of these robotic processes that,
yes,
although it'll have to be somewhat...
Yes, I'll answer to you to that. I just put here in the private chat, you can put it in the side chat for everyone, Nature's Robots, a history of proteins, and the link. So
okay, this is what I was saying.
Can I actually answer now?
So yeah, sorry, I was getting ahead of myself.
So proteins are actually robots, and I'll give you here a syllogism. Machines, robots, fully automated manufacturing production lines, transport carriers, turbines, transistors, computers, and factories are always set up by intelligent designers. Too, science has discovered that cells are literally chemical nanofactories that operate based on molecular machines, protein robots, kinesin protein carriers, autonomous self-regulated production lines, generate energy through turbines, neuron transistors, and computers. Therefore, most probably, cell factories containing all those things are the product of an intelligent designer. So I disagree with you, Matt, that we see actually robots in nature because proteins are robots. They are self-regulated. They know, for example, exactly how to measure when there is sufficient DNA or not sufficient DNA. And then there are signaling methods which then say to the cell, okay, there is a shortage of DNA, produce more, or there is too much DNA, stop production. So we have here a self-regulating factory which knows how to operate and how always to make the right number of products which are needed in the cell. So this is not...
You need to give him a second to respond. You're monologuing again.
Yeah. Sorry.
So this is what I was trying to get at. It's one of the problems that you have in science communication, because that's what I'd really, really love to be. It's kind of like my dream job at the moment would be like general science communicator. I wouldn't generally do these debates as part of that, so don't worry. This is just a side thing for hopefully it's useful though to people. But this is why you have a problem. The book you said, I don't have enough time to look into it to see who the author was or whether they're coming from a certain point of view. But when scientists talk about things like that, when we say that it's like a cell factory, we are not saying it's a factory in the exact same sense as a human factory. It's not a production line in the same sense. A lot of the time when they show these things, it's because it's metaphors that make things easier for people to understand. But as I said, that can lead to problems because it can blur things a bit. It can make things too simplified. I've just put a link myself in the chat too to a paper called "Mind the Metaphor" that's talking about what I am. It's a fascinating read, and it specifically goes into the DNA being a code example and why that can't really be it. So you'll find scientists everywhere, and to try and bring this back to the topic of why scientists don't generally conclude the same things that you are here, is that they're analogies, they're metaphors. It doesn't mean it's a factory. And if you want to bring up the chemical processes that sustain life, it is so incredibly inefficient. Like if you look at the human body, we have DNA for our entire body in each and every one of our cells. It's a waste. We have so many waste products in our body that don't need to be there either. Like if you're going to say it's an intelligently designed machine, at best it's a poor designer. I make the joke so many times with people, but I want, if I ever find the person who designed my body, I want a refund. These processes, when we talk about a factory like that, it's not that it's actually a factory. And as I said, I can't have a look specifically at that book, but it sounds like maybe they're more already on your side. So unless I hear specific examples, I don't think we're going to go too far. But yeah, that's my kind of answer to that at this point, without obviously having a chance to go and read the book.
Yeah, so let me answer in regards of your claim that the human body isn't so effective. I quote here from the science paper, Alton Oxner, MD, Thoughts on the Human Body from 2010. Let me put here the link in the site chat, so you can have after a look on it. Let me just quote here about 2 sentences, okay? When we arrive on this earth, we are endowed with the most perfect, the most efficient, the best constructed machine ever devised, our body.
Nope. Sorry, already disagree with that. It is not an efficient one.
Matt, let him finish.
Please,
yeah, sorry.
I'm permitting you to finish the sentences.
I got it at 10.
I would like you to grant the same to me, okay?
Yeah, I got it. Move on.
Okay, so a machine beautifully engineered and constructed with the best materials, with no planned obsolescence, constructed with material of superb quality, destined with proper use to last long periods of time. The body's computer, the brain, is by far the most sophisticated, the finest constructed, the most efficient computer that has ever been or ever will be designed. No man-made computer can approach the efficiency of the computer each of us has. I could go on. There are many other things here outlined. But the key point here, Matt, is that even if what you are saying is true, and if the human body or whatever biological system you want to mention would not be perfect or as efficient as you would like it to be, that is to compare it to a cell phone where you say that the tastature, where the keyboard isn't perfect, and then you say, okay, that cell phone wasn't designed because the keyboard is not perfect. Of course, you would never make that conclusion. And the same goes with systems in biology. Even if you can claim that some systems aren't perfect, that doesn't mean automatically that therefore then no designer was required.
Okay, so I strongly disagree with quite a bit of that, because the idea that, and this is why, again, we've got to be careful with the language and the metaphors. When you're going to talk about the brain as a computer, it doesn't operate the same way as a regular computer. And this is why it's a bit like, how long is a piece of string, or is this a hot object? Well, what are we referring it to? So when you're going to say that the human brain is a computer, that is better than any that's ever going to be built. That's already been shown wrong. We can build computers that can do most of our functions fairly well, and there's currently a lot of work into neural nets that will probably be able to, in a few decades, surpass what we're doing. But yeah, it's a bit of whatifism, so I can leave that one aside. I'll go down this one. How many calculations, simple like multiplications, can you do in your head in one go? Like in, say, the space of a minute?
I don't know.
Because I'm pretty sure I could write a program in a few minutes that on this computer alone would outdo both of us, like by several orders of magnitude. And this is the thing with computers, is that they're fairly specific. Like they're good at doing the tasks that humans are not good at doing. That's how they're designed. So to say that a computer can be creative like us or can't be creative like us, well, we've already got computers that can paint. We have them that can beat us at our own games. If you want to talk about computers that will solve certain problems like chemical problems, well, then you can go into quantum computing and look at how they operate differently to these ones. The bottom line is that we now can make computers that will do most of the functions we do a lot better. So that, alongside the other things we point out, like the best materials, we're not made out of the best materials. Our bones, for example, mistake mercury for calcium if it gets into our body in the right form, if it's methyl or ethyl mercury. That's just one of the chemical examples that comes to mind. Then it's not perfect material. Like our bones, if we miss out on one or two chemicals, will break incredibly easily. Like I had a cyst in my upper arm when I was little, and it completely shattered from a small impact. I've dislocated my kneecap several times. It's not made out of great material. If it's intelligently designed, it could have done a lot better job. There's the typical one about the laryngeal nerve, but the human brain is not the most powerful computer we can design, and it's not an efficient system because it has trouble repairing itself. Like if you have a computer and it's got viruses, you can at least write programs that will go through and try and fix them up, but the brain doesn't do that very well. Like once you start, like certain brain cells can repair themselves, particularly those for smell, if anyone's wondering. I think that's because those are the ones that are likely to get damaged, or most likely to get damaged. But inside the brain, it doesn't tend to repair itself very well either, which is not how you would design a system if you had it. I could sit here and come up with very specific ways that I could make the human body better. Like I could, specifically for the eyes, because I can go into the optics of it. I could go into the teeth. Like I would actually switch out the chlorine for fluoride to start with, which is why we put fluoride in the water, because it reduces our stuff for the chance of it decaying. It increases it moves. It's a chemical equilibrium, but it makes it more stable. So I can sit here and come up with better ways. So I just don't buy the line that human body is well designed, or that you can prove somehow that it's supernaturally done. Sorry, I'll end there.
Let's give Otangelo a second. Now we are reaching the hour mark. We have surpassed the hour mark actually, so we need to work on wrapping this up. I don't want to push you guys, but plan on wrapping your arguments up because we still have super chats and a few questions to go. So Otangelo, go ahead. Quickly respond.
Yeah, sorry, can I just ask one thing in terms of wrapping it up then?
Yeah.
Okay, is there any topic, Otangelo, that you want to get to, even if it means cutting some of the others short? Is there something you wanted to address?
Well, we have addressed in a short time bones, calcium, computers, and so forth, the human body. So, I mean, each of these topics would require much more time to go deeper into the details, and each one of us making their point. So I would like just to address what you said in regards of computers, and just quote here quickly from an article I've put in the side chat, the link, so everyone can look it up. And here goes. A typical healthy brain houses some 200 billion nerve cells, which are connected to one another via hundreds of trillions of synapses. Each synapse functions like a microprocessor, and tens of thousands of them can connect a single neuron to other nerve cells. In the cerebral cortex alone, there are roughly 125 trillion synapses, which is about how many stars fill 1,500 Milky Way galaxies. One synapse by itself is more like a microprocessor with both memory storage and information processing elements than a mere one-off switch. In fact, one synapse may contain in order of 1,000 molecular scale switches. A single human brain has more switches than all the computers and routers and internet connections on Earth. I mean, sorry, Matt, but what you said that you could do make a computer better than the one that we have, that is something which I think the evidence doesn't lead to that conclusion. And I mean, in regards of the human body, we have 37 trillion cells, and each single human cell has about 2 billion proteins. So if you sum up the number of proteins in the human body, it is 1 to 10 to the 22nd power. That is the number of stars in the entire universe. And now if you ask yourself, how did evolution make such a complex being? And the fact is that each single cell has to be in the right place in the body, in the right organelle. There are about 200 different cell types which have to be separated, and each organelle has to have the right cells, the right type of cell. We are talking here about a kind of complexity that we have far from being even coming close to investigate fully how it operates and how it works. So saying that you think that you can do better than nature, what we see in nature, that is, in my understanding, completely misplaced.
To the last point, because there is a bit there to address in terms of being able to do better than nature. I could sit down and with anyone, and I think because we're about to wrap up, maybe we can leave it for another time, and I could give you ways of improving the human body, which would suggest that it's not the perfect design. Yes, that doesn't 100% prove that it wasn't designed. Well, it had nothing to do with intelligence, but it proves that it wasn't very well designed, at least. Now, like as I said, I can go into specifics with the eye, but we can leave that for another one. But in terms of that, I mean, big numbers, as I said, it's relevant to what? Now, with these connections for computers, I'll go back to the earlier thing I asked you. How many calculations can your head do? Like, how many mathematical operations could you do in a minute? As I said, I could write a program right now that will outdo that. It depends on what you're measuring. You can't sit down and look at this big number and go, therefore it's the best. Jupiter's the largest planet in the solar system. That doesn't mean it's the best.
I can answer you here and quote you here from another paper. Even Peterson, PetaCruncher, setting a course toward ultra-fast supercomputing. And it says the human brain is frequently likened to a supercomputer. In most respects, the brain greatly exceeds any computer's capabilities. Speed is one area where the computer beats the brain, at least in some ways. For example, few of us can quickly multiply 0.0239 times 854.95. This task is called a floating point operation because the decimal points floats until we or a computer decide where to place it. The number of floating point operations per second is the measure of a computer's speed. As for 2013, China's Tianhe supercomputer holds the record at 33,900 trillion flops or petaflops. One challenge is to prevent these super-fast computers from overheating because too much electricity, electrically generated heat is dissipated in a too small volume. Now, the human brain itself serves in some sense as proof of concept, and its dense network of neurons apparently operates at the petaflops or higher level. Yet the whole device fits in a 1 liter box and uses only about 10 watts of power. That's hard act to follow. So the technology in our brain is far, far superior and not and unmatched by far by what we have made so far.
Well, again, it's how long is a piece of string. It depends what you're referring it to. Now, one of the things that computers, you could argue, are not better at us with is for like the creative aspects, being able to think independently, though we are getting to the point where that is also changing. It's just the way things are going. But big numbers, so what? Do you know how many data points like a radio telescope, for example, could get in a single survey? It's in the order of like terabytes, like in a few minutes. Our human brain could not process that information in a lifetime. It's relevant about what you're doing it. We've designed computers to do certain tasks. So in other tasks that we're already good at, yes, can't outdo us. Now, this idea that, the human brain is like a supercomputer operating at 10 watts, well, it's impressive, but nature's had, 3.5 billion years to work on it. Whereas we've had, a couple of decades to work on our computers. The large numbers are, yes,
Matt, the problem which
they're impressive on it.
Yeah, let me add. I mean, the problem which I have with that, Matt, is that if we take each single neuron and then have a closer look at how it actually operates and how it can actually create action potentials, then your number of millions of years simply becomes meaningless. Why? Because there are 4 essential channels in neurons which are necessary for a neuron to work. If one is missing, then nerve cells and neurons cannot operate and create action potentials. And there would be no multicellular organism on Earth. Essential means they are irreducible and interdependent. And these 4 channels, if you remove one of them, then you have actual potential. So they are necessary to emerge all at once, because by their own, any of these channels, they have no function. They only can operate in a joint venture. So how do you explain that by evolutionary gradative process, where first one channel would evolve and then a second and a third, if they only operate and work all together?
Okay, I'm going to let Matt answer this question, and then we're going to wrap it up.
That's the irreducible complexity argument. I think that's been addressed by other people a lot better than I could here. So I will mainly refer to that. But again, these chemicals could have evolved simultaneously. And again, the nervous system didn't evolve, like, it didn't originate the way it operates now. It's slowly over time. It's like the idea of that you need all 4 chemical systems to work the way they do. That's now. That doesn't mean that in the past you needed all 4 of them to work and that they had to come at the same time. No, you generally had them repurposed slowly over time. But as I said, other people have addressed that one better, and biology is not my strong suit, so I'll keep it nice and short.
Okay, so a couple things here. For the most part, the chat is mirrored Matt for the most part, but that's kind of expected here. But excuse me. First off, we want to thank you to Cryptomaria. Has become a new member. Thank you. We got a $2 Australian super chat from Darth Dawkins. Why does Otangelo bother with these simple fools? And then another one from Darth, $2 Australian. The Bible says so. That's all the evidence needed. Now, there is a couple quotes here I wanted to get into. Not a whole lot of questions, really. High Inquisitor says, Dear Theist, doesn't typing on the Sabbath go against your rules? Tangelo, just real quick, do you believe in the Sabbath?
Well, I don't hold it. I think in the New Testament we are not obligated to keep the Sabbath.
Okay. Iron Chandelier says religion creates black and white thinking, leaving no room for gray areas. And you had anything you want to say to that one real quick? Otangelo?
Yeah, either God exists or not. I don't think there is an in-between. It cannot be both. God cannot exist and not exist at the same time. So this is a true dichotomy. And if someone wants to propose a third option, go for it.
Okay. No, for the most part, I'd agree with that. But if I may just add one little thing to it.
Go ahead, Matt.
Okay, so... Oh, yes, and I'm glad you brought that up. I will answer any super chat. So if anyone has a question, bring it up. But my point to that is that, yes, I would say that, by the nature of the statement is a dichotomy. Either there exists a God or there isn't. But what I would say in that is that if you want to talk about supernatural entities that potentially had something to do with the origin of the universe, it doesn't necessarily have to be an intelligent God or a God of, like, say, the Bible. There are a lot more options when you start to break it down. But yeah, at the very basis, I would agree that, at least from a philosophical point of view, that makes sense. But in terms of where we can, where we can reside in our thoughts, there are three options: those two plus the "I don't know" option, or the just withholding from taking a position, which is for the general purposes of theism where I sit.
Okay, hang on, just there's something here I need to look for.
Yeah, just
real
to
quick.
add, I don't know is not another ontological option. So it's just a state of understanding where you declare that you don't know another option. But
Yeah,
of
and
course,
that's why I said if you're
I
talking
mean,
about our
I mean,
understanding.
if you're
Sorry,
talking about plural gods or different natural mechanisms, of course you can subdivide them. But basically, you can put everything in two buckets and two categories. In one, there is an intelligent, ultimate, necessary personal creator, and in the other bucket, there is none.
Okay, apparently I got it wrong. Apparently it wasn't iron. Did I say chandelier? I meant iron charioteer. Charioteer, iron charioteer. Sorry, I think I said iron chandelier. Okay. Another one from iron charioteer. Fermentation was also most likely involved prebiotically. Good example with the booze mat. Cheers. $2 super chat from Darth Dawkins again. What is your primary? What is your ultimate primary, and why is it not God? And why is it God? And then okay, from Cryptomaria. Okay, if there is an intelligent design, why would God put guys' bits all hanging out? Maybe God didn't know people would invent Zipter. I feel sorry for men.
Yeah, I think what Dart was asking is why is the ultimate not God? Probably he forgot to put the not. So that is probably a question to Matt.
it's not the real Darth Dawkins. Don't worry.
Okay.
I am curious to get your answer on that other question, though. On the other statement, your response.
Oh,
Which
why
was
did
the other
God make guys' bits hanging out?
Yeah, because there are clearly parts of the human body that are not very well designed, or at least that don't operate very well. No, Otangelo, what do you say to those?
Well, of course I disagree. I think that the human body is amazingly designed. We still don't even understand a fraction of how it works. And I mean, if you look into each single cell, then it just amazes me in regards of the complexity. Like even just one molecular machine like the ribosome, which requires machines that make the soup parts of the ribosome, and it had to merge prebiotically. How do you explain that?
Well, as I said, like that's not my area for abiogenesis, but I will say that yes, the human body is complex, but that's not the hallmark of intelligent design. Like intelligence, the hallmark of design is simplicity. Doing what you need to in the simplest, most efficient way, not the most complex way.
Yeah, simplicity is meaningless, Matt, if you don't get the intended function. So you cannot make a clock or a watch just with one single atom. You need a specific set of interlocked parts in order to have a specific function. And when you look into the human body, then it isn't over-engineered. It is engineered in the sense that it provides the function that it is intended to have, like eyes to see, ears to hear, the stomach to digest, and legs to walk, arms to do several things, and so forth. So I disagree with you. I think, and when you come to specified complexity and instructional irreducible complexity, these are clearly hallmarks of design, and there is plenty of examples in nature where we see both, where we see DNA, where there is stored specified complexity, and molecular machines which are irreducible, which are composed of several parts, and the subparts they have by their own no function. They only work in a joint venture with other parts. So evolution couldn't explain the origin of those.
Okay.
The
last rebuttal, and I'm going to shut it down.
Oh, okay. Very quickly. Well, on that, then, why is our optical nerve connected to the retina the wrong? Like, why are our cells all the wrong way? Why do we have a blind spot then? When we know there's a better way of doing it, you could design our eyes to be like cephalopod eyes, or give us a bigger lens. We'll see better, just based on the diffraction limit. Terms of, our hearts are not a great. Our hearts are not a great design, because if they stop for, well, if you're an adult, if they stop for 20 minutes, you'll be pretty much brain dead unless someone's helping you, and even then, it's quite iffy. A lot of our internal things you brought up, stomach acid. Well, everybody gets reflux every now and then because the valves don't work and the acid goes the wrong way. So, and if you want about needlessly complex, every single cell in our bodies, from the dead skin, well, the skin cells and the dead ones as well, to the retinas in our eyes, to the stomach, the ones that line our stomach, to the cardio muscles and the heart, contain a full sequence of our DNA. All of it. It does not need to. They are specified. They only need a small portion of that, but they contain all of it. That's not an efficient method. So if you want to talk about complexity to get the task done, they're overly complex. And you would expect that with evolution, you wouldn't with intelligent design. Sorry.
Okay, so Chris has offered for you guys to continue this discussion next week if you guys want to. It is completely up to the two of you. Email us. We'll go back and forth and make sure we get everything set up if you want, or if you want to change it to a different topic, that's also an option. One thing
I might want to pull it back towards physics a bit more, because that way that's a bit closer to my area, and I'm not. I just know a bit more on that one.
I do have a question though for Otangelo. Have you taken any anatomy and physiology courses?
No, I'm a layman, and I'm an autodidact. I just read books and science papers on the web, try to understand them, and that's how I get my information.
I can tell you from experience, because I have taken an A&P class. If you take an actual A&P class, a lot of your questions about why things don't work or why things do work will be answered. An AP class would break it all the way down to what the cells do and everything like that. So, just a simple suggestion to just take a simple anatomy and physiology class can actually answer a lot of your questions.
Now, just to quickly answer to Matt, most
real
of
quick,
these
and then we got to wrap it up.
Yeah, just most of these objections of bad design, like the inverted retina and so forth, these are things which have been answered, and there is no bad design in regards of these classical examples, like the laryngeal nerve and so forth.
All right. So thank you everyone that was here to join us this week. This was an interesting discussion between Matt and Otangelo. It kind of went off topic of what the topic actually was supposed to be, but that happens when you actually have a fluid discussion. Thank you all for being here. Thank you for the super chats. Thank you to the new members. Thank you to the old members, and everyone else watching now and in the future. Thank you for joining us. I have been Jay. And this has been Hereticals, Difference of Opinion. Let's talk. Thank you to our guests, Matt and Otangelo. We hope to see you guys next week. If anybody has a debate or a conversation with someone in that they want to have, doesn't matter what the topic is. It could be as far as does pineapple, belong on pizza. Doesn't matter. If you need a place you want to talk, you need a place you want to have a discussion, no matter what it is. Get a hold of us at hereticals6pack@gmail.com. I believe it's in the description. If it's not, we will get it in there. Or you can find it on other videos. Get a hold of myself or get a hold of Chris, and we can set that up for you. Thank you, everybody, for joining us. And until next time, be water, my friends.